Hello students and welcome to the e-learning program initiated by Shri Gyan Manjri Vidyapeeth for the students of Standard 10, in which we are learning the subject of social science. Students, the previous three lectures we had started with chapter number 12, that is minerals and energy resources. This is lecture number 4 for chapter 12. Let us take a quick recap of what we have learned in the previous lectures. Requirements of primitive men were limited. Their only means was survival, so they did not need a lot of things for their survival. And nature helped them a lot. They needed food, which they gathered. They needed food, for which they hunted with small weapons made with either wood or bones, stones, whatever. And they did not have the need to keep it because they didn't have a house. They didn't have the idea of a house. They didn't need to keep the food for next day. Next day again it was morning, just like all other animals people used to. The primitive men used to again go out searching for food, whether it is uh, plants, fruits, tree roots, leaves, or the fruit of the trees or the fruit of the plants. They search for it, or they hunted and killed animals and ate them raw in the earlier time when they didn't know the use of fire. For shelter from rain, wind, they took shelter under the tree, under the rocks, or they found out caves later on and lived in it. So they did not have much needs. So where need is not there, then requirements, because requirement is less, then needs are also quite less, and that is why there was no advancement. But during the process of evaluation, lots of things changed, and slowly men learned how to live together for protection purpose. Then they started with the agriculture, made house, villages. So slowly requirements increased. So evaluation process of the humans is divided into three stages mostly. Various stages, for example, Stone Age, then came the Bronze Age, then came the Iron Age, and then the Modern Age, that is today's age, which we also call the Atomic Age, which started with the dropping of the bombs of Hiroshima and Nagasaki, and that led to a new path of having energy from the radioactive elements. And now we have started using positive way by making electricity out of the radioactive elements that are present in the earth. So this is called atomic age also. Understanding the definition of minerals that we did. Minerals, they are made with the process of abiotic process, which goes on in the interior of the earth. And then we divided, or we classified, the minerals into various ways. For example, we classified them as solid, liquids, and gases. We also classified minerals according to the way we use it. Yes, some of them are precious metals, some of them are day-to-day metals that we use. Some of them are used for mixing purpose. One mineral is mixed with another mineral so that we get a different metal. So we classify them again into metallic. Many of the minerals, they have metallic properties. Many of them do not have metals in them. So we classified them as metallic minerals, non-metallic minerals, and minerals used as energy resources. Metallic minerals, we learnt iron, then manganese, copper, bauxite, mica. These are, sorry, uptal bauxite, metallic minerals, then mica, lead, limestone, they are all non-metallic minerals. In metallic minerals, we learned that they are available in the raw form. That means the ore. Then each and every mineral has a different refining process. Then for iron, we learned that the pure iron that we get from the furnace, it's called pig iron. We have 4 different kinds of iron that is produced in India. The name of the ore changes. Then we get iron, high grade iron or lower grade iron. Then we learned about the uses of iron, states producing iron. Same way we learnt about manganese. Where do we get manganese? The state producing it. What are the different uses of manganese? And how is the refinement process done? Same way copper, the refinement process, the uses of copper, the properties of copper, how it is used, and major states that are producing copper. Same way we learnt about bauxite, which is the ore of aluminum, and the uses of aluminum, state producing aluminum, the properties of aluminum that we learned. Then we learnt about mica, lead, limestone. Same way, then we learnt about coal as an energy resource. First thing is how coal came into existence, or how did coal form. Coal was formed millions of years ago, that we learned. Yes, it is a process where because millions and billions of years ago there was quite a lot of vegetation on the earth because of the movement of the tectonic plates. The forest, whole of the forest got buried under the ground, and it kept on going down because of the pressure from the top and heat received from the bottom. The water content of the vegetation, it got evaporated, and because of the constant heat received from the bottom and pressure on the top, only the carbon remained, and that became quite solid. So this period is known as Carboniferous period, where the vegetation turned into coal. Same way, petroleum also, same thing happened, but in a little differently. That is, many aquatic animals, lots of vegetation got buried together, and lots of water content was there in these aquatic animals and the animals. So instead of turning into solid coal, they turned into uh, hydrocarbons. Rather than turning into carbon, that is coal, they turned into hydrocarbons in a very viscous, that is quite thicky and sticky liquid that today we know as crude oil or mineral oil. Same way, natural gas, uh, it will be available in both the ways. Wherever mineral oil is available, on the top part, the mineral oil which gets heated up from the bottom because of the core activities, the petroleum gets converted into natural gas. Many of the places natural gas is available without mineral oil also. Then we learnt about the non-conventional or renewable resources, that is solar energy. We trap the solar energy, the sun rays, they help us in moving the solar energy is trapped and used in producing electricity. So we can produce electricity from the solar energy or the insolation that we receive. uh, Next was again a non-conventional energy, that is renewable energy, that is wind energy. We are able to uh, move the windmills because of the wind energy, and that is used to rotate the turbine and thus produce electricity, right? So up till here we have learnt. Now another uh, non-conventional energy is biogas. We use biotic elements to produce gas, that is biogas. The gas produced by decomposition of agricultural waste, molasses, that is remains of the sugarcane, other vegetation, dung, and human excreta is called biogas. A tank is made under the ground where we dump all the organic waste over there. It can be any of the agricultural waste that is available in the field that we can dump over there. Molasses, that is the crushed sugarcane. After crushing it and extracting sugarcane juice, the remains can be dumped over there because it is organic matter, and when it is buried under the ground, it starts decomposing because water is added to it. It starts decomposing, and because it's a biological matter, so gas is produced. Other vegetation, suppose we use kitchen, we have lots of wastage over there, vegetable, etc. Decayed vegetable also, which cannot be sold in the market, that can be dumped over there. dung. The farmers they keep cows and buffalo, that is cattle, for milking, producing milk. So the dung, the excreta of the animals plus excreta of the human beings also can be dumped into this. The lid can be closed and then allowed to stay and decay, and the gas produced from it can be collected with the help of a pipeline coming out from the tank, and then it can be used in the kitchen, etc. So uh, biogas mainly contains methane. Yes, it is the same thing that we get in the cylinders, right? That is natural gas, but when we burn it, blue color flame comes out of it. So biogas mainly contains methane. Methane is an inflammable gas which is primarily used for cooking purposes. The biogas that is produced, it's not in huge quantity, because then we need that much waste over there. So we do not have that much. So slowly, a little bit amount of gas can be collected, it can be compressed and kept, and we can use it for daily purpose. If the biogas plant is quite huge, then lots of houses in the surrounding can use the biogas that is produced for the purpose of cooking. Thus we will be saving the natural gas, which is non-renewable, or it is exhaustible. So here we are using the bio waste that we collect, and we produce gas which can burn or which can uh, be used for cooking purpose. Thus biogas is more preferred over natural gas. After extracting biogas, the material remains behind in the biogas pit is used as an excellent natural fertilizer. As we have discussed just now, that all the bio waste is dumped over there. Yes, whatever agricultural waste, etc., we dump it over there, and all of that is organic waste, right? So when gas is produced out of it, it turns into black colored material, which is excellent as manure. So we can open up the pit and we can extract uh, whatever material remains behind. We can extract it and we can spread it in the field, and that can be used as a natural fertilizer. So we, from the same organic matter that was no use to us, we used it to produce gas, plus the remains can be used in the field as natural fertilizer. So actually we can keep the environment clean, because bio waste or organic waste that we just throw out in the open, it keeps decaying and gives out foul smell and also pollutes the atmosphere environment. So instead of that, we put it in the biogas plant and we allow it to decay to produce gas for us. The whatever is remaining, we can use it as a natural fertilizer. We can keep our villages clean by producing biogas and also obtain natural fertilizer. Once we have obtained the biogas, it is completely non-polluting, because it is inflammable, it burns completely and leaves no pollution behind. So we can keep our villages and the environment of the villages quite clean. Otherwise farmers will be dumping all those agricultural waste here and there, and it will be giving foul smell. It cannot be even used by the cattle to eat. Plus cattle also produce lots of excreta, so the dung and all that. So we can use all of that and keep the environment clean. In India, Uttar Pradesh stands first in biogas production. Gujarat ranks second. It is very good. Uttar Pradesh, UP at first position in producing biogas. We are at second position. The largest biogas plant of Gujarat has been installed at Metham village near Sidhpur in Patan district, and this plant runs with cooperation of villages. All the villages, they help in dumping all the organic or the agricultural waste and the vegetable waste, whatever, in dumping into that biggest, largest bioplant, and it helps in producing a lot of biogas, which all the villages, it is distributed evenly to all the villages, and thus they save a lot of money, and they also get natural fertilizer, and they don't have to pay for LPG cylinders. Other biogas plants in operation are located at Rudratal of Daskoi Taluka of Ahmedabad, and also one of the biogas plant is at Dantewada, that is in Banaskantha districts. People also have started setting up plants that they are operated individually or collectively. Yes, individually in a small house there is not much to dump into the biogas. So individually it will be quite costly, and uh, if the family is too small, then uh, lots of agricultural waste etc. is not available. So it has to be done collectively. But still, small biogas plants can be installed on an individual basis, and it can help you in saving a lot of money and keeping the environment clean. Next we come to geothermal energy, the heat, that is the thermal energy. For that, we have to understand that at the core of Earth, we have learned that in the previous earlier standards, we have learned that the Earth is divided into three levels. The top part is known as crust, then comes the mantle, and the last one is the core. Core is where all the elements, all the minerals are in pure liquid form. And because of the intense heat over there, lots of pressure is created. This pressure tries to come outside, but because of that, quite a lengthy layer of mantle is present over there, so it does not get enough space, that pressure does not get enough space to come outside, and it keeps cooking inside. But because of the intense pressure created, the pressure tries to come out at some point. So usually it tries to come out through the cracks available in the rocks in the mantle section. When it comes to the crust part, the layer is quite thin, so there it can come out. So that is what we are talking about. The heat or the thermal energy generated and stored naturally in the interior of the earth is called geothermal energy. This energy comes out to the surface. When it comes out to the surface, that means it crosses the core part, it crosses the mantle part, and then it comes to the crust part, and it comes above that also. So when it comes, we know because of that pressure and heat also. So if water is available over there, then it will heat up the water. Heating up of water is going to create steam. That steam can be stored, and that is the geothermal energy we are talking about. This energy comes out to the surface of the earth in form of geysers or hot springs. Lots of heat is constantly available because of those cracks, and the water over there keeps on getting heated up. We can collect the steam, and we can use the steam to rotate the generator, and we can produce electricity. The heat in the interior of the earth heats the water stored in the earth. So vapor rises from this hot water and exerts upward pressure, that we know, on the ground. The vapor is then released out in the form of steam. This is called geothermal energy. Because of the constant heat produced inside, it keeps on coming outside and touches the water layer somewhere and heats up the water. So water, when heated up, produces steam, and this steam we can collect, and we can turn the turbines with the help, and we can produce energy from it. In Gujarat, hot water springs are located at lots of places. One of that is Lasundra. We have in Unai, Tua at Tulsi Sham also. Tulsi Sham is in Gir. So lots of people must have visited that. Yes, it's quite small place, and not a lot of heat energy is produced over there, right? But it has the potential of producing energy from it. These are possibilities. There are possibilities of getting geothermal energy from them. Possibilities are there, but because the place is too small and the water content is also not that much big, so lots of steam cannot be produced over there, because we need lots of steam and we have to collect the steam in order that a turbine can be turned. Next is tidal energy. Now, what is tidal energy? Yes, you must have been near the seashore and you must have seen the tide coming towards the shore, and there will be times when tide is going away from the shore. The water recedes inside and it goes quite far back, right? So these are the two tides that we are talking about. Both the tides, power is there, because if you stand over there, you can see that, you can feel that power where it touches your feet, or if you are say waist deep, you can feel that surge of waves coming towards you and it imbalances you. So that is the power that we are talking about. That power can be utilized, or that power can be harnessed in turning the turbines. If it turns the blades, turbine turns and we can produce electricity. So gravitational force, how is that? How are the tide coming? Because of the gravitational force of the sun and the moon. There are two big things near us. One is the moon, one is the sun, right? So gravitational force exerted by the sun and the moon causes tides. Tides, they have two names. Yes, the tide which is coming and the tide which is going back, right? So tide which is coming, we just simply call it tide. The water which is receding backwards towards the sea or the ocean, that's called ebb. So tides and ebb continuously happen in the ocean or the sea, and it's a clockwise, it is always a particular time. It has a cycle. Once the tide comes, it has to get over and it has to go back again. After certain time, again the tide starts coming. So whether the tide is coming or whether the tide is going, yes, it can turn the turbine. The force of tide and ebbs can be utilized to produce tidal energy. A turbine is connected to generate electricity from these tides. So you can say a simple box like thing where inside is the turbine and the blades are outside. So whenever the tide is coming, it can rotate clockwise. Whenever the tide is going back, it can rotate anti-clockwise, and thus whether it rotates this way or that way, the turbine turns and produces electricity, right? So tidal waves are quite useful in producing electricity, and this is renewable resource of energy, non-exhaustive because they keep on coming and going back. So non-exhaustive and non-conventional also. A new way to produce electricity. In 1910, France was the first country to get electricity with the help of tides and ebb. So 1910 to 2010, 100 years, complete century, we have advanced quite a lot. So lots of countries are now trying to produce electricity with the help of the tidal waves, and it's not that cheap, but then you always have free electricity because tides keep on coming and going. So you always have whatever small quantity of electricity that you can produce, but it is helpful in saving a lot of money and resources. India has a huge coastline, so India has a very good potential. India is not, we do not have that many plants where tidal energy can be produced, but because we have a very big shoreline on the all the Asian continent, Asian countries, so we have quite a high potential of producing tidal energy. Gujarat has started the project in the Gulf of Kutch and the Gulf of Khambat to produce tidal energy. Gulf of Kutch is where Kutch is on the other side, right? And Gulf of Khambat is where we are living, right? So this is Gulf of, this is Gulf of Khambat, right? Please remember this so that you can get the exact location, yes, and the names also. Preservation of minerals and its need. Why is this point taken up? Because we are talking about minerals. Minerals are exhaustible. Once we use up all the reserves that we have, it's over, it's finished, right? Then the future generation is not going to enjoy the development that we are enjoying because they won't have minerals at all. So this is the first point, that we should be aware now and start utilizing minerals in such a way that we conserve also and we preserve also. We use it and also allow some of that to be used in the future. For the future generation, they also should have the minerals so that they also can enjoy the minerals in the future, plus they can also enjoy the development that we are having. Minerals are the base of existence and development of human beings. We cannot stop the development of human beings. Yes, so development keeps on happening. More the development, more the consumption of minerals. Preservation of minerals means the efficient and well planned use of minerals. That is called preservation of anything. Preservation of anything is a well planned way to use it. Right? So, preservation of minerals is a well planned and an efficient way to use the minerals. So, we can also use it and we can preserve and conserve for the future also. Today, every nation wants to increase its export as a part of economic development. If you want economic development, there are two ways. Either you sell your raw material, for example, you sell your iron ore, you are going to get money, or you dig up the iron ore, you purify that in the iron and steel plant, and then you make iron and steel out of it and then export. Right? So either way, for your economic development, we have to use the minerals. So today, every nation, it has a need to increase its economical development, and for that part, they need to export as much as possible. Yes? For this, it keeps on extracting more and more minerals from the earth to produce goods and then to export them to earn foreign exchange. That is what we discussed right now. Whether it is ore of any mineral, we just dig out the ore and sell it raw. That means without refining it, or we refine it and then make something out of it and export. Either way, our aim is earning foreign exchange. Right? For that, we are constantly digging up as much as we can from the earth so that we can sell it. For this, we keep on extracting more and more and minerals from the earth to produce goods and export them to earn the rich foreign exchange. If this is not stopped or it is not planned well, our mineral resources will end soon. First thing is, we have learnt about it, that we should know the total quantity that we are having. Then we should know per year what is our consumption. Then we can calculate that this reserve will last for this many years or this many decades, right? Then we come to know, then we become aware that after, say, if that quantity is going to last us for another 60 years, but then we should also remember, after 60 years what will we do? Today we dig it up and sell it outside, or we dig it up, refine it, make something and then sell out. After all, we are digging up all our reserves. Now if that gets over in 60 years, then we do not have anything to sell because we cannot produce anything. Remedies to preserve minerals. First thing is use of proper technology. Why use of proper technology? Wastage of minerals can be reduced by making use of proper and advanced technology for extracting minerals. We can understand this point with the help of some other example. For example, a truck that is produced 1 month back, that means it has the latest technology, right? Engine is made out of latest technology. The transmission system, that means the system which transmits power to the rear wheel or the front wheel, whatever, whole of that is transmission system. The braking system which applies brakes, right? All of that is also made with the latest science and technology. The body of the vehicle is made out with the latest technology so that it gains more speed, travels longer distance in shorter time. Fuel efficiency is the best thing that can be said over here. We make more and more advanced machines that uses the fuel to the best efficient way. Earlier cars were made that had, say, a mileage of 10 kilometers per liter, right? So we used to have a huge tank over there which houses at least 40, 50 or more than that liters of fuel. So when the truck is used, we have fuel efficiency, we have a good braking system, we have good engines, uh, the power it can produce is good enough, the load it can take is more, and compare that with a truck that is already 20 years old. That engine, it's quite old and it is going to use fuel like anything. So if the new truck gives you an average of say 20 kilometers per liter, that old one is not going to give you 10 kilometers also per liter, right? So the old one and the new one, what is the difference? The difference is good technology. Lots of wastage is done if technology is not used properly in even extracting, because lots of spills will be there, lots of unnecessary, the raw material has to be thrown away because the system that is refining it or extracting it is not of the latest technology, right? So wastage of minerals can be reduced by making proper and advanced technology of extracting the minerals. Next, very very important, recycling. Now you just imagine that we keep on digging iron ore, we produce say bars of iron and we use it, and when it's of no use we just throw it away. We again extract, make new and use it. So every time we need it we have to extract and make iron bars and then use it. Rather than that, the things that are of no use now can again be melted. So time, energy and the natural resources can be used or utilized quite efficiently. Then that much less iron ore we have to extract. For example, we have the shipbreaking industry over here. Then it helps in lessening the quantity of iron ore that is required by the country, because the ships are broken over here, yes, into parts, and then it is melted again, and again sheets or iron bars are made out of it and sold in the market. So that much less quantity of iron ore we have to dig it. That is in one way saving for the future, because by recycling we completely have a new thing. So the scrap of minerals like iron, copper, aluminum and tin should be recycled and reused, so that we do not have the requirement of digging out more and more or extracting more and more of the ore, and then that means we are depleting the reserves that we have, we are lessening the reserves that we are having. So recycling and reusing is one of the method of preservation, or it's a remedy for preservation of minerals. Alternate use of minerals. What do we understand by alternate use of minerals? For example, the benches that we are using right now, yes, you sit on it and we use the benches for our daily studies. Now those benches are made out of two things. One is the iron that is used as a stand, and one is the wood that is used for sitting and writing purposes. If plastic is used over here, then we will be saving a lot of wood. Wood is becoming quite costly because the demand is more, and the forests that are kept separate for furniture purpose, that is less. So the prices of wood is going up, right? And we are cutting down the forest, we are cutting down the green cover that we are having. We are lessening it. So if we switch to the alternative, earlier days, in many of the days today also, you must have seen the switchboards that are used for switches of electric fans and tubes and all that. They are made out of wood, and there is that Sanmaika cover on top of it. But the new houses that are made, that are constructed, they use a plastic switchboard instead of wood. We have replaced with an alternative. Thus, lots of wood is saved because we don't use it in the switchboards. So, alternate use of minerals should be found out. Alternatives should be found for minerals which exist in less quantity. So minerals are already, many of these minerals, say copper, lead, they are now available quite less, right? Because whatever was there, we keep on using it, and now the quantity has become less. So wherever it is used, we must try to find an alternative so that we don't need copper, we can use something else. For example, we have done that thing. When copper became so expensive because we used in the wires, we replaced it with aluminum, because aluminum is available everywhere and it's quite cheap. So we found an alternate, but now we need to find an alternate for many of the minerals which are becoming less and less in quantity because we keep on extracting that from the earth. For example, making use of the solar energy instead of electricity, a very good replacement, rather than using, because we use coal in the thermal power plants, because coal is burnt over there to heat up the water, hard water, and uh, used to collect the steam, and that steam compressed and then released so that the turbines can move and produce electricity. Instead of that, small quantity, but we are using lots of power plants, small solar power plants all over India, thus reducing our requirement to get all the power from thermal stations. So thermal stations are now less of use because so much electricity is provided by the uh, hydel power, or you can say wind energy or solar energy. We have found alternate means of producing electricity so that we don't need coal. So we are saving coal in one way. So, and solar energy instead of electricity, aluminum instead of copper, that example we took, CNG instead of petrol. Yes, CNG. Why? Because petroleum is more costly. Gas is a little bit cheap over here. Both are exhaustible, but then one is costlier, one is less expensive. So we can save lots of crude oil and we can use gas. Yes, if we don't use gas, it might leak from somewhere and it can escape into the atmosphere, and then we are going to lose it. So why not harness it and use it so that we can save crude oil? Use of non-conventional means. The use of non-conventional resources like water, solar, wind, biogas should be increased. Water over here, we mean the hydroelectricity. Yes, we collect water somewhere in a dam and then allow it to fall on the generator or the fans of the turbines and produce electricity. Same way, a waterfall is there, we can put a small plant over there which the water will keep on falling on the fans of the generator or the machine which produces electricity, and then we can produce electricity in a small quantity that is sufficient enough for few houses. So thus we are saving lots of energy because we are using non-conventional means. Same way we can use solar energy, wind energy, geothermal energy, biogas, etc., so that that much less burden is on the exhaustible resources, that is coal, crude oil, uh, radioactive elements, etc. Sustainability. Sustainability means we should be able to sustain, and that should be for a longer duration. Attempts should be made to maintain the priority of the environment so that coming generations can have a clean environment. We keep on using, for example, crude oil for getting petroleum and uh, diesel, etc. We burn that in our transports, and we produce lots of smoke and pollution. Instead of that, if we are using CNG in transport vehicles, then will not be polluting the environment, and our environment can be kept clean, and the future generation can also enjoy a more cleaner environment. Yes, for all these factories, etc., we are producing lots and lots of minerals, extracting them, using the refineries to produce them. So if we use alternate means, we can stop that pollution, and we can reduce the pollution in the environment and keep the environment clean. Attempts should be made for a pollution-free environment. Once the mineral reserves are properly estimated, planning should be done for utilizing it effectively and efficiently. This step is very important to preserve and enhance the minerals. For example, all the coal. We now have a complete picture of India where coal is available in which quantity, which type and which quantity. Now we know because satellites also help us in mapping the reserves and to finding out new reserves, etc. So now we have a total quantity which is under the ground. So that first step is done, measuring the total quantity that you have. Then you bring your yearly reserve, yearly consumption. How much do you need each year? How much does our country need each year? How much do we consume of that particular mineral? So now you have the total quantity, now you have per year, so you can have an exact figure how much longer or till what time you will have this mineral, you can use this mineral, right? After that particular time, whole of whatever reserve we have consumed it, and we have no more of it. So we got to plan it today. That is the second step, that if we start using it at the current rate at which we are using, then it will exhaust, and then we will have no more. So right plan needs to be done right now, that we need to reduce our consumption, or we need to put a ceiling that if we want this reserve to continue for the next 80 years, then we need to consume only this figure only. If only this much is to be consumed, then it will last forever. Then we need to put a ceiling that from the ground only this much mineral can be extracted per year. After that has been extracted, we have to shut down the extraction, and we can again resume digging the next year only. So that forcefully we have to limit our usage, our consumption, so that the mineral can be used for the longer duration of time, and we can also keep the quantity and quality of the mineral intact. Modern age is known as a mineral age. This is a give reason, or it's a question also. Same thing, we have done this already, but this is just a way of answering. Requirements of primitive men are limited. He worked only to sustain his life. Men conquered great heights, evolution happened, and technology developed. Science and technology developed. In today's days, minerals, they play a very important part in our life and progress. In Stone Age, men used stones for hunting. Now he is traveling into space, so requirement increased, minerals use also increased. Minerals use has been tremendously increased after the Industrial Revolution. With time, new inventions keep on coming, developments keep on happening, and in all the fields. So every day, some or other product comes up in the world market. All these inventions and discoveries result in producing products to cater to the demand from the people. We use lots of gadgets, vehicles, services, etc. compared to the past. All of this involves the use of minerals, so we can say the modern age is mineral age. We come to a very important question. Sustainable use of energy is the only way to a bright bright future, that we already understood. Only thing is we have to answer it in a different way. With the time, new invention, development keep on taking place in the fields. This demands extraction of more and more use of minerals. World has become a small place. It's called a global village. Every nation wants to grow its economy. For that, it keeps on digging out the minerals, researching about the new products, manufacturing them, exporting so that they can get money. All these processes needs extraction of more and more minerals, and that is a stress on the depleting or the becoming less of the minerals under the ground. Minerals and energy resources are available in limited quantity only, whereas we are increasing the use of it day by day. The future generation will not be able to use the mineral resources, and the future of that world will be quite dark, because they will have no more of the minerals. All the minerals we have exhausted during our lifetime. So the future will have no minerals, and they will be having a dark age. We are living in a mineral age. They will be living in a dark age because we have used up all the minerals. Moreover, excessive use of these mineral resources has polluted the environment also. So the environment is going from bad to worse each and every year, and this is also not good for the future generation, because we have deteriorated its quality. So with this, we finish our today's lecture, and we also complete chapter number 12. Thank you, students.